First step in this problem is identifying interesting groups that we have. And we see here that there is a ketal. So we know first that we're going to have to protonate one of these two groups. And by looking at the product, we know we're going to want to protonate this group. Well, either way it doesn't matter actually, because this will just end up popping off and it's going to form a ketone. So we'll protonate first. This is our nucleophile here attacking our hydronium. So in essence what we've done, we have created a good leaving group here. So what we're going to do is we're going to take these source of electrons and push them down, which will kick off these electrons because we don't want to have a Texas carbon. So we'll end up looking like this. Okay, so that oxygen is now positively charged. We don't want that, so what we do in this workup with the water and the hydronium is we're going to have water come in, which is acting as our nucleophile. Will come in and attack this electrophilic carbon and push these electrons up onto the oxygen. Okay. So now what we can do is we can do this in one step. We're going to deprotonate this up here, and we're going to protonate this oxygen. Now what this is doing is going to make it so that we're able to form our ketone, which was originally in our ketal group. And that should be pointing down. Okay, so now we have a good leaving group here. What we're going to do is we're going to use this source of electrons, push them down, push that over there, and it'll kick off, and we'll have our ketone. Now that will just get deprotonated, and we're not going to end up using this guy again. Okay, so based on the products, we know that we're going to want to form with this carbonyl group. We're going to want to protonate that, so making a more electrophilic carbon down here, so that this alcohol can come in and attack here and then push up the electrons onto this oxygen. Oops. So this will come down. Oops. Hydrogen get protonated. Okay. Now this right here is going to act as our nucleophile. It's got the lone pairs of electrons will come in, attack at that carbon, push it up to there. Oops. And we'll number our carbons. 1, 2, 3, 4. So I'll have that down. So this is 1, 2, 3. On the third one, we have the OH, the alcohol. There's that. That. Have that with the positive charge on that oxygen. And then we will have to deprotonate there. We'll do that with water. Okay, now we're at the point where we're almost near our product, but we're going to want to make one of these alcohols a leaving group. It doesn't matter which one. So we're going to protonate it with the hydronium. And as you can see, we have the correct number of carbons, 1, 2, 3, 4. We haven't lost any in the process, which is good. Okay, so now this will serve as our source of electrons to come and kick this off, just like we would do if it was an ester. Come down, that gets kicked off. Now that is still positive up there, so we're going to want to deprotonate it, and then we will have our product. So we'll take in water, act as our nucleophile, rips off the proton, and then we're left with our carbonyl ketone group with our oxygen there as an ester, and there's our alcohol, and that's our product.